Hello and welcome to the IzzyAcademy Show. This is our inaugural episode. On this show, we're going to be discussing different news items, techniques, tutorials, how-tos, and all the tips and strategies that have to do with everything regarding application development, data workloads, and how to run those applications and data workloads successfully in cloud and sometimes hybrid environments. So that's pretty much a high-level summary of what these shows and episodes are going to be about. Now, a couple of days ago, I sent out a call for participation on Instagram and Twitter, and I was asking you to send in questions regarding different topics you would like to hear me answer and discuss during this inaugural episode. So in the future, if you would like to participate, you can post your question either as a video or as a text on Instagram and Twitter using the hashtag #AskIzzyAcademy. And you can also send me your question directly either as a voice memo or as a text, written text email by sending it to ask@IzzyAcademy.com. So that's pretty much how you can get to participate in upcoming episodes. For today's episode, we're going to be discussing 4 different topics. So the questions may fall into one or more of these categories, where we will discuss career decisions, hiring decisions, different data workloads, different open source data workloads, and how to make those choices, as well as techniques and strategies on how to deploy these workloads in the cloud environment, or even in hybrid scenarios where you want to do on-prem and cloud. So that's pretty much what today's episode is going to be about. Now, for upcoming episodes, we will be talking about different open source data workloads that have to do with event stream processing. So these are technologies like the Apache Kafka ecosystem, the Apache Flink ecosystem, and all the different techniques and strategies that have to do with making choices using those technologies. We will also talk about how to select different open source data workloads, whether that is for key value stores, whether that is for relational stores, wide column stores, search servers, graph databases, all those different workloads. We'll be doing a deep dive into all those different topics. We will also talk about different errors where you may encounter when setting up or running all these open source data workloads. So this has to do with the root cause of those errors, and also how to prevent those errors in your future or current deployment and workloads. Now, there may also be some episodes where we bring up all the recent developments and news items that have to do with things that just got released for the Apache Kafka project, for KSQL, for Apache Flink, Elastic Search, Neo4j, Kubernetes, Apache Spark. And I also have experience in software engineering, so we may also discuss things like Angular and Spring Boot. So this is some of the areas where we may discuss some news items. Now, some of the things that I may also cover would be different tips and strategies on how to prepare for interviews, whether you are the one being interviewed or whether you are the one doing the interviewing. So we can also talk about that. And we may also discuss recent and relevant technology conferences, like the ones organized by O'Reilly, the Flink Forward Conference, the Apache Kafka Summit, and all the different technologies where open source technologies are being discussed, like the cloud native conferences where things like Kubernetes are being discussed extensively. So another thing I want to talk about is all the different certifications that are now making waves. So we have the CNCF certifications for Kubernetes. We have the Confluent certification for Apache Kafka. We have the Databricks for Spark. We have the Elastic for the Elasticsearch ecosystem. We also have the Neo4j certification. So these are some of the things we're going to be talking about. Now, again, if you would like to participate, just remember you send in your questions as a voice memo or as a text to my email address, ask@IzzyAcademy.com. You can also post those questions on Twitter or Instagram using the hashtag Ask Izzy Academy. So now let's take a look at what we have for today's episode, and let's get started with answering some of these questions. Question number 1. So our very first question comes from Matthias from Palo Alto, California. So Matthias is asking, what is your show about? Is it about Kafka, technology, or the meaning of life? So Matthias is actually an Apache Kafka PMC member, I think, or a committer. So I have co-presented with Matthias on the recent Apache Kafka summit that was virtual. Now, so I know him, and I think I already responded to him what the show is about. So I'm just going to answer it again one more time. Basically, like I said in the introduction, the show is all about discussing different ongoing events, some of the news items. We will also discuss some tutorials. We'll also talk about some of the tips and strategies that you can use and best practices on deploying some of the different workloads, open source workloads for data stores, for applications, for stream processing. So pretty much in all the different areas where I have experience in, I may be the one to do the discussion. And in some episodes, I may also invite guests that are experts in these areas to come and discuss them. So just stay tuned for that. Now, the show will also discuss things that have to do with Kafka. It will also talk about technology, and maybe sometimes, who knows, we may discuss what the meaning of life is. But the show is just going to be about open source technologies for data workloads, for application development, and how to run all those different things successfully in cloud environments. So pretty much everything that has to do with those topics, we will discuss it. Now, our next question is from Cynthia from Burlington. I think this is Vermont. So Cynthia is asking, I'm a computer science major and I'm looking to explore a career in data, but the field is so broad and I get confused between the terms data scientist, data engineer, and data operations. So what are the differences and similarities between these roles, and which one do you think I should pursue? So this is a very loaded question. What I would recommend here is there is a book, I think, from Jesse. Now, if you research, I think his name is Jesse Anderson. If you research the book Data Teams, he goes into an in-depth analysis of discussing these 3 different career options. But what I would say is, if you are interested in exploring these career options, first try to understand what it is these people are doing, and then find out which one would be a best fit with your skills and interest, and then you go ahead and pursue that. But basically, to answer your question, the differences is that the data scientists, and sometimes they may call them data analysts. They are very good with coming up with all the algorithms that are going to be doing the data analysis. So they design the algorithms, they analyze the data, and they're very good with coming up with all the different formulas, so to speak, that is used in doing this data analysis. Now, the engineer is someone that is very hands-on with picking the right technology and tools to perform the data analysis. So they will write the code, they will compile the code, they would sometimes assist in the deployment of the code, and that's what the engineer does. So the scientist pretty much comes up with the blueprint and with the maybe the algorithm and the design for that, and then the data engineer will go ahead and implement that. The data scientist is very good with the domain knowledge and tell the data engineer what kind of formulas they would like to use. Now, the operations person is also another team member here, but here this person is more involved in the deployment of the infrastructure, and they get to manage the infrastructure that is supporting what the data scientists came up with, what the engineer has implemented, and they go ahead and deploy all these different workloads and monitor them. There's also another one that I would like to bring up, the data architect, which kind of oversees the architecture and the design of the different implementations. And the data architect is going to pretty much provide a very high level guidance on why we should pick a particular technologies, and sometimes they give a guidance on how it should be set up so that it is secure, it is performant, and it is going to accomplish the objectives of the business team. So that's pretty much high level. Now, as for the one that I think you should pursue, what I think you need to do is just pick which option you have the most interest in, and which option, which one your experience is going to align with. So that's it for that question. I hope I was able to answer it, Cynthia. All right, so now let's take a look at the next question. So the next question is from Manuela from Winter Park, Florida, not far away from me. Manuela says, congrats on your inaugural episode and thanks for taking my question. I'm a software engineer with 4 years experience in Java, and I'm looking to get started with data engineering. And I am thinking about relocating to a different city where there are better job opportunities. What cities do you recommend, and what technologies should I get started with? What technologies do you suggest I get started with? So Manuela is a Java developer with 4 years experience. Now with the current COVID situation, I don't really think you have to think about relocating to a different city. You mentioned here that you have experience with Java, but you did not indicate whether you're already a Java a data engineer. So you're exploring that. So what I would recommend here is get started with reading some books about the different data tools that are available for performing data analysis. And then once you do this, they should give you an idea of all the different tools that are involved. And then I will recommend you set up hypothetical projects where you can implement these projects using the tools that you would like. So this will give you hands-on experience in all these different data technologies. So now right now, if we're performing batch analysis, the tools that are available for that in the market today would be Apache Spark or Apache Flink. Typically, that's what most people are using today for doing batch workloads. For real-time analysis, the most popular that I've seen is Kafka. So Apache Kafka is very good with analyzing data in real time. It has a very broad ecosystem that supports that. So you have tools like Kafka Streams. You also have tools like KSQL that allows you to perform real-time analysis and transformations on these different data sets. So those are the two tools that I would recommend you get familiar with. You may also want to explore learning Python, because some of the data engineering that comes up is going to be using Python for that. So you have to be very, very good at that. Understanding Scala, understanding Java, understanding Python will make you a very good data engineer, depending on what your team is doing. So pretty much just take a look at some of the different job openings that are open. Look at what those particular skills are looking for. And now, and I would say maybe for the next 2 years, most of the jobs are going to be remote. So you don't have to relocate to any specific city to get a job. If you are very good at what you are doing, the job will come to you, and you can pretty much work from anywhere for any city in the US or for pretty much any country in the world where your skills will be needed and where you have the permit to work in that location. So I hope that answers all the questions you had. So I don't have to recommend any specific city. The technologies that you would get started with, I just brought them up: Apache Kafka, an Apache Flink for real-time analysis. And then for batch workloads, I would say take a look at Spark, take a look at Apache Flink, and some people may use Apache Beam, but those are the two that I'm comfortable with. Now, the different cloud providers would have their own native tools that allows you to perform this analysis. So I'm not going to box you into any specific technology when it comes to selecting a cloud provider, but regarding open source software, those are the ones that I would recommend. All right, so let's take a look at the next question. Our next question is from Cynthia from Austin, Texas. So Cynthia is saying, I just want to say thank you very much for creating this forum for us. I appreciate you making yourself available to answer the questions. I'm a technology manager in a large healthcare organization looking to add new talent to our team. It's hard to find new data engineers and operations people in our area. So what are your thoughts regarding how we should source for talent? So this particular question has to do with finding data engineers and operations people to add to the team. So what I would recommend here is that sometimes it is hard to find data engineers and people that are in operations for a particular location. But right now, most of the jobs are going to be remote. So I would say you have to be open. I don't know what the requirements are, but you should be able to hire people from pretty much any part of the US and even outside the country if you can do that. But what I have to recommend is that you may not really find data engineers. So you may have to find software engineers that are good with Python, Java, Scala, and pretty much all those different technologies. And then sometimes you may have to coach them and groom them to become available to you as data engineers. So any good software engineer that is very strong with those technologies should be able to carry over the skills in whatever they're doing right now into supporting you in your data workloads. It might take them a little bit of time to ramp up, but I think a good software engineer that is strong in the technologies that you're using today should be able to ramp up within maybe 4 to 6 months, and they should be very strong data engineers, and you should be able to find them. Now, regarding location, I don't really think you have to be tied down to a specific location. If they have access to the internet and they have a dedicated location where they can work, I think that should be enough for you to get started. So regarding operations, these are people that are very good with setting up this infrastructure. So they also have to understand the different tunings. So this one is a little bit harder because the operations people have to understand how to deploy and how to configure all these different technology options that we are using. So if it's Kafka, they have to understand the Kafka Connect ecosystem, how to set up brokers, how to set up Zookeeper, how to configure all those different components to make it work successfully. So if you're looking to hire people in operations, what I would say is you go to the different mailing list. You may see people that are very good in answering administrator questions. So if it's Kafka, if it's Flink, if it is Apache Beam, whatever technology you are interested in the mailing list, you should be able to find talent. You can also search on LinkedIn and Stack Overflow, find people that are answering these questions, and those people would be a good place for you to start. Even if they're not available to join your team, they may be able to recommend you to other people who are looking for work at this time. So that's what I would recommend on how to get started. So just to summarize, think about a way of hiring software engineers to convert them to data engineers. If you're not able to find data engineers in your area, open up the net and make it remote so that you can bring people from outside your locality, and then For operations, you can go to the forums to find the experts. You can go to LinkedIn to find the experts. And then you can also, if they're not available for the role, they should be able to recommend you to other people in their network that are interested in the role. So let's take a look at the next question. I hope I was able to answer that question. Oh, this one is very brief. So this is Pedro from Billings, Montana, I believe, MT. What is a fair salary for a data engineer? So for this particular question, I'm not sure if this is the person that is looking for a job or this is the person that is hiring. So I'm going to try to answer it from both sides. So the salary for a data engineer typically has to do with the responsibilities of that job. It also has to do with the experience of the person that is coming in to the role. It may also depend on the locality and the cost of living of where the person is living. So if somebody is in Montana and they're trying to compare that to living in New York or living in Silicon Valley, then the cost of living is going to be different. So the cost of living can also influence the salary. The skills and expertise of the person would also influence that. The level of experience of the person and what the job responsibility is going to be is also going to influence that. And then another factor you have to bring into this is the economics of the area. So right now there is a lot of jobs everywhere, but there is not really much talent to fill those positions. So if you compare that, the supply and demand is causing the price to get adjusted. So because of the fact that we have more demand than we have supply of data engineers, I would say the salary is going to be quite high. So what I would recommend you do is take a look at the different career websites, maybe Indeed, maybe LinkedIn, and you can see what people are offering for these particular roles based on the area, based on the roles and responsibilities, and based on whether they're looking for an entry-level person, an intermediate-level person, a data or a senior person. So that really has a lot to do with the salary. So depending on which side of the fence you are on, if you are the person that is being hired, take a look at your skills, take a look at what you have to bring to the table, take a look at your cost of living, take a look at the competition in that market, and that should influence what you're going to be paid or what you're going to be paying the person. So I hope, Pedro, that answers your question. I'm going to take a look at the next question now. So the next question is from Virginia, and Virginia is from Sacramento, California. So Virginia says, I'm very new to stream processing, and I get overwhelmed with all the open source choices in the market. I have started reading up on Kafka, Pulsar, Beam, Spark, and Flink. What are some of the resources you recommend to get started with? So, Virginia, these different technologies, if we're going to break them down, they fall into two major categories. Some of them fall into both categories. So, we have batch processing, which deals with a fixed set of data. We also have what I would say event stream processing. So this has to do with unbounded data sets and the technologies that we use to process them. So these technologies that you're talking about are going to fall into one or both of those two categories. So I actually have a course which I'm going to put the link in the show notes or in the description, where you can take a look at the different strategies when it comes to picking these technologies. So on the event stream processing side, that deals with unbounded data sets, meaning that the data is coming in real time, and as it's coming, you are processing them, you are enriching them, you are transforming them, and doing all of that in real time. So for the event stream processing, where you're dealing with, again, with unbounded data sets, you can use technologies like Apache Kafka that has a very rich ecosystem. Sometimes I can also use Flink. Flink is very good with this. So Flink and Kafka is what I am very comfortable with at the moment. But I've also seen a lot of people use Beam and Pulsar for doing event stream processing. But the most common technology today, from my perspective, is Apache Kafka and Apache Flink. Apache Kafka has two components in the ecosystem that allows you to process these unbounded data streams. So the Kafka Stream Framework is a Java or Scala API that allows you to pull data out of Kafka, enrich it in real time, and push it back into Kafka. At a very high level, that is what it's doing. So you get to react to the real-time streams of data that is coming in, and you can process that in real time and push it back. Flink also has similar capabilities, but Flink is not really for storing the data. So Kafka has a component that allows you to store the data, and also it's a separate component that allows you to process the data. But with Flink, it's more focused on just processing. So Flink has a Java API as well. It also has a SQL API that allows you to respond to these real-time streams. Kafka also has another component called KSQL, but this is not part of the open source project. It is a community licensed project that is done by Confluent, the official commercial entity behind Apache Kafka. So for real-time processing, I typically go with Kafka or Flink, depending on what I'm connecting to, how I'm transforming it, and what I want to do in my logic. So Kafka and Flink for that. Others may also use Beam and Spark, Beam and Pulsar for that. Spark has a component for doing stream processing, but most of it, from my perspective, is, I think, micro batching. So I would stick with Kafka for this, either using Kafka streams or using KSQL to do to perform the processing. Or I can use Flink, which I have some experience in that as well. Now, for batch analysis, this is dealing with bounded data sets. So bounded data sets mean that you have a fixed amount of information you want to process. So the data, the number of records or number of items or number of events you're dealing with, it's not going to be changing once you started to process the information. So for this, I will go with Spark as my number one option. So the Apache Spark project is very, very good for doing this. It also has different connectors to different data sources and data sinks. So you can pull data in from different sources, enrich it, and then push it back into the same or a different data store. So again, in my course, which I'm going to put a link in the show notes or description area, you can click on that and take a look at the different strategies for doing this when it comes to picking a batch processing technology. So Apache Spark will be my first option. Flink will be the next one. And then Beam can also support batch workloads. So one thing that you're going to notice is that some of these technologies, they fall into the two categories. Either they do batch or they do real time, but some of them can do both. So Flink and Beam, I think went into a lot of effort to consolidate the API so that you can have the same tool support doing batch and doing stream processing workloads. But I still think that there are certain areas where Flink has the upper hand when dealing with either real-time or batch workloads. And if you try to compare that with Spark, Spark may also have an advantage. So all these different tools, I would say you have to play with them, take a look at your scenario and see which one would work best for your particular scenario based on all the different use cases that you have. Again, if you are interested, you can take a look at my course, and that would guide you as to how to pick one of these technologies. So let's take a look at the next question. Next question is from Sami from Barcelona. So Sami says, IzzyAcademy, what are the differences between batch and real-time stream processing? And what are some of the open source tools you recommend for these workloads? So I think I just briefly covered this in my previous question. So when we're dealing with batch workloads, the main idea here is that you're dealing with a fixed data set. Your data set is not going to be changing once you have started the processing. So if you think of this as maybe people arriving at an airport and they're going to be going to a particular hotel, this is pre-COVID or maybe even today. If you think about batch workloads, so in a batch workload scenario, the metaphor here would be that all the passengers coming from all the different flights will have to wait, and then once we get enough passengers to fill the bus, then everyone will now go to the hotel as one group. So in this scenario, once the bus is leaving, all the passengers have already arrived, and no other passenger is coming because we are doing the transfer of passengers to the hotel once all the passengers have arrived and our passenger list is fixed. Now, in a real-time scenario, you may think of this as having some kind of conveyor belt or escalator or some kind of a transport system whereby it is constantly pulling people into the hotel. So as soon as any customer from any flight arrives, it just takes them directly into the hotel without having to wait until everyone is present for us to go. So batch workloads and real-time workloads are very similar in terms of the ETL that you're doing, but one of the key differences you have to pay attention to is that with batch workloads, the data set is fixed and it does not change once you've started to process it. But with real-time stream processing, the data is a stream and it's constantly changing as you are doing the processing. So now when it comes to the tools and frameworks, for batch, I typically recommend Apache Spark and Flink for that. And for real time, my number one choice my number one tool of choice is going with the Apache Kafka ecosystem. So I will set up Kafka to store the data. Then I would set up either KSQL or Kafka streams to react to these data streams as they come in. Some of my colleagues and friends, they prefer to go with Apache Flink, but my preferred tool where I have the most experience is with Kafka. So that's what I would do. But again, I would urge you to take a look at the different options that are available and then pick the one that works best for your scenario. So you don't want to make the mistake of picking the wrong tool for the job just because that's what you're comfortable with. Always try to go with what works best for that scenario in the short and long term. So that will be my recommendation for that. So I hope that answered the question. Now let's take a look at the next question. The next question is from Marsha from Toronto. So Marsha is saying, thanks, congrats on your new show. So my question is about the thought process in selecting relational databases or wide column stores. How do you distinguish between columnar stores and relational stores, and when do you use each one? Which one do you recommend for these workloads? Okay, so this particular question is about picking a wide column store and a relational store. And I'm thinking we're dealing specifically just with open source ones, since that is what was called out here. So what I am going to recommend is take a look at the different documentations for these databases, and in summary, a wide column store is different from a relational store in how the data is stored. Relational databases typically keep all the columns or all the fields that belong to the same record as a single unit. So if you need to retrieve any of the columns in a relational database, all the different fields and all the different columns for this record will be retrieved together. So if you need to perform something like an aggregate where you want to find the average, maybe the average size of a particular product or the average revenue for a particular product, what you're going to do is you're going to have to retrieve all the other columns for the product entity and then discard all of them and then focus on just the one that you need. So when it comes to performing aggregates on specific columns, the relational store is going to be less performant. Also, it does not matter if a particular record has that column. All the records in the database entity or table must have, all these fields. On the other side, if you have scanty columns where some records don't have certain fields, or you want to perform analysis on just one particular column, maybe like an aggregate, find the minimum value, find the maximum value, find the average, standard deviation, all those aggregation specific queries on specific columns. Because of how the Y column store keeps track of all these different data sets, you can pick a Y column store for that particular use case. So in this scenario, because columns are stored together, if you want to perform an average value, perform a computation that is doing the average of a particular column, then all you have to do is retrieve just that one column. You don't have to retrieve all the columns and discard them, which, is very wasteful. But because of this, the Y column store will be a very good use case for this. The data can be compressed because all of them are from the same data type. And there are so many advantages with using a Y column store for this particular use case. So that is at a very high level, the main differences between the two of them. And again, the workload that I will pick, there are so many different options. HBase and Cassandra, is one of the popular Y column stores. There are also other open source ones. And depending on your cloud provider, you may also have Y column stores or relational databases that are available for a particular cloud provider. For open source relational databases, I have experience and I'm familiar with Postgres and MySQL and MariaDB. Now there are other ones that are also available, but I would go with Postgres or MySQL with this particular use case. So I think that summarizes it. Again, the main differences is how they store data. One keeps it as columns and the other one keeps it as rows, and they have different use cases for that, and they have different advantages. And if you want to know more about this, I have a course that answers exactly how to pick these different databases. So you can take a look at the show notes or the description area, and you should be able to see the link for that. So let's take a look at the next question. So this question is from Mike, and Mike is from a city in Western Australia known as Perth. So Mike says, thank you very much in advance for taking my questions. I'm an operations engineer and we're looking into using Kubernetes to host our Postgres databases. What are your thoughts when it comes to using Kubernetes for database hosting? So this is a very popular question nowadays. A lot of people are looking into using Kubernetes for running different data stores like graph databases, like key value stores, like relational databases, pretty much all the different data stores that you would imagine. People are looking into using Kubernetes for doing that as well. One reason for doing this could be because you're already using Kubernetes for all other part of your systems like microservices, data processing, and all those different workloads, and you have this extra inventory available, so you may want to use Kubernetes for that. But when it comes to deploying data stores on Kubernetes, you have to be very familiar with how Kubernetes works. So having the knowledge about persistent volume, having the knowledge about managing secrets, managing config maps, managing the networking, routing traffic into your different data stores, all those different components of of Kubernetes is something that you have to be very familiar with, in addition to running your data store in a container. So it is not always as straightforward as doing it on a virtual machine, or even using the platform as a service offering from your cloud provider. So when it comes to doing this, I would say that you need to have significant experience running Kubernetes. You also have a lot. You also need to have a lot of experience running this particular data store by itself before bringing it to Kubernetes. If you have these two backgrounds, then I would say you can go ahead. But for production, I always recommend using a platform as a service offering from the cloud provider in which your environment is running. That is going to be my best option and my recommendation. But regarding running Kubernetes, running the data store in Kubernetes, I've also seen a lot of people using this for their development environment. So all the lower environments, they run their data stores on Kubernetes. This has several advantages because it creates isolation, in which you don't have to share a particular a single instance of a data store with multiple developers, which brings a lot of headache. Every developer can set up their own container, set up a namespace, or they run it in their own local cluster, and it would be a very consistent experience across multiple environments. So in general, I recommend running the platform as a service offering from your cloud provider, because that takes the responsibility off of you. But in your local environment, in your development or lower environments, Kubernetes can be a very good option in providing you a consistent experience across multiple environments, starting from your local development environment to your test environment, to your staging environment, and all those other pre-production environments. So I think Kubernetes is going to be a very good idea for that scenario, but not for production. I'm not yet comfortable doing it for production. That would be my experience, because most people that want to do this don't really have the database experience, the Kubernetes experience, and both sides of the coin to be successful in doing this without having major problems. So without going into much details, that would be my recommendation. But I have seen people run different data workloads successfully in production without issues. But for the average person, this will take a lot of effort to do this successfully. So if you don't really have significant experience, I do not recommend doing this in production. And I would recommend you can do this in lower environments, but for production, pick something that is provided by and managed by someone else, and then you just get to focus on your domain expertise and your application, and not worry about what's happening at the data store, especially if that data is very critical. So I hope I was able to answer this particular question. This is the last question that we have. So let's take a look at what's coming up in future episodes. So like I said before, we're going to be covering different data workloads when it comes to event stream processing technologies. So we'll cover extensively the Kafka ecosystem, which includes Kafka streams, the Kafka broker, the Kafka producer and consumer APIs, the KSQL, and all the different connect frameworks, tools that we have within the ecosystem. We will also cover some updates coming up in these areas. And then I also plan to talk about Apache Flink, Apache Beam, and Apache Pulsar in future episodes. I will also do a deep dive on picking the right open source data stores, depending on what you're doing, whether that is a key value store, a relational store, a wide column store, a graph store, search server, document store, all those different data stores. I have upcoming episodes that are going to be dedicated just for picking the right data store. We'll also talk about, from time to time, there will be how-tos and strategy discussions on dealing with common errors how to prevent these errors, and how to resolve these errors if you're already having them. And then we'll talk about upcoming developments, some of the news items that are available for different open source data workloads like Apache Kafka, KSQL, Flink, Elastic, the ecosystem, Neo4j, Kubernetes, Spark, Angular, and Spring or Spring Boot. Then we'll also discuss different tips and strategies for people that are interviewing others and people that are going for interviews to be interviewed. So we'll discuss that across the different domain areas. And then we'll also discuss relevant technology conferences that are coming up and the current industry certifications, the Kubernetes certifications, the Confluent, Databricks, Elastic, and Neo4j certifications that are available. So that's what I have for future episodes that are coming up. If you would like to participate in an upcoming episode of the IzzyAcademy Show, please send your questions either as a video or as a text. And you can post that on Instagram or Twitter using the hashtag #AskIzzyAcademy. And you can also send me a voice memo or a written email to my email at ask@izzyacademy.com. So that is ask@izzyacademy.com. And for Instagram and Twitter, it's going to be hashtag #AskIzzyAcademy. And please subscribe to the channel. And don't forget, if this video has been useful to you and you think others will benefit, please feel free to share the video with others. Wherever you're finding this video, whether it's on YouTube, on Instagram, or Twitter, please feel free to share with other people that you believe will find this very beneficial. And if you like my videos, please feel free to subscribe to my channels or follow me on Twitter or Instagram, and like this video and send me your feedbacks on future topics and future items you would like to be discussed on the show. So once again, thank you very much for staying to the end. I really appreciate your time, and I look forward to sharing more content with you as I have them available in the future. Thank you very much.